Hello students. Next we will look into the properties of Z transform. Here again we will look at the same properties that we have seen for Laplace transform, for Fourier transform. The properties remain the same, but the results may vary slightly. Okay. Starting with the first property, which is the linearity property. As written here, the linearity property states that if we are having two functions, one is x1 of n and the second one is x2 of n, each having its Fourier transform, not Fourier, sorry, Z transform of x1 of z and x2 of z with some ROC. When I have written R1, what you have to see is that it might be something like magnitude of z is greater than or less than some value a. That is what is the ROC generally. So that ROC region is being represented as some region R1 and some region R2. Then linearity property says that if you have such two functions, then you can multiply them with some constant a, some constant b, add them together, then for the whole function like this, a x1 of n plus b x2 of n, the Z transform will be a multiplied with the Z transform of x1 plus b multiplied with the Z transform of x2, and then the region of convergence will be the intersection of both the regions. Intersection of both the regions means, see, we have already seen in set theory that suppose there is a region of one set like this and another set like this, then where the two overlap, those two regions, those region is basically called as the intersection of the two regions. So similar to that, if suppose I am having one region of the ROC which basically looks, let's say, something like this, in which this is outside, and another region is suppose region is suppose for the second circle, which has the region of convergence ROC to be inside this red circle, then you can see that the green and the red will be both overlapping in between these two circles in the shape of a ring. Outside that, it will not overlap. So that overlapping is basically the intersection between the two regions. So this is what the linearity property says. Let us go and prove for the linearity property. It's very simple. The proof says that the Z transform of the whole a x1 of n plus b x2 of n can be split into two parts. That means you can find out the Z transform of the first function plus Z transform of the second function, where since a is a constant, you can take that constant outside and then it becomes a the Z transform of x1 of n and b the Z transform of x2 of n, where we know that this is where we know that this one, the Z transform of x1 of z is x1z, the Z transform of x2 of n is x2 of z. So we have basically reduced it to get the answer. Now we already know that for yx1 of z, that means if the whole function x of z has to exist, then each of these individual functions should exist. Now the function x1 of z will exist for a region R1, and the function x2 of z will be for a region R2. And if you want this whole function to exist, then both of this should simultaneously exist for some value of z. That means for some region of convergence, both this function and this function both must exist. Therefore, there has to be some common region wherein both of these will exist, because of which x of z will exist. That is why we are saying that if ROC of x1 of z is R1 and the region of convergence of x2 is R2, then for both to exist there must be a common region in the z plane, and that common region will be the intersection of R1 and R2. Hence the ROC of x of z will be the intersection of R1 and R2. Next is the time shifting property. In the time shifting property, it says that if you know a function whose z transform you already know with its region of convergence being R, some region, then if you are time shifting that function x of n with some x of n minus m, then it is as good as multiplying the x of z with z raised to power minus m, where the value of minus m here has come from this minus m. Okay, so if you already know some function whose z transform you know, then delaying that function basically means multiplying that function with z raised to power minus m. Remember, here if it is going to be plus, here it will be plus m. Okay, so and what will happen to the ROC? See, ROC is R. If such a case happens, then the time shifting property says that with ROC is equal to R, but there will be a possible addition or deletion of origin or infinity from this R. Okay, that means with this R there will be either an addition or deletion of the origin. For example, if you are having an ROC which looks like this, suppose if you have ROC which looks let's say like this, so this is the circle and outside of that circle, suppose this is the ROC that we are currently having, then if there is time shifting, because of which there is a function like this, you will have this new ROC will be the original ROC plus either the addition of origin, okay, or there will be a deletion of the infinity. That means in infinity whatever is happening, that is deleted. So the region of convergence will not include either the infinity, or it will include the origin. Or if suppose the the region of convergence is basically some circle with ROC being inside the circle, this we know this happens for a left-handed sequence, then with this particular property, if there is a shift if there is a time shift, then in the new ROC the origin will be deleted, and there will be the inclusion of the infinity. That means the region of convergence will now be this circle devoid of the origin, plus at the infinity there will be ROC. So these things is something that we have to prove. So let us prove that. Now we know that the proof is very simple, that the z transform of x of n is x of z, wherein the formula is that x of n multiplied with z raised to power minus n summation minus infinity to plus infinity. Therefore the z transform of x of n minus m, all you have to do is, instead of x of n I am going to write x of n minus m. Now this n minus m I am going to substitute, with p. Therefore what all will I have to substitute? I will substitute, instead of n minus m I will put p. Now instead of n, what it will be? From here n minus m is equal to p means n will be equal to m plus p. Okay, so instead of this n I will put m plus p. and that is exactly what we did here. So I have put z is equal to x of p into z raised to power minus m minus p, out of which z raised to power minus m can be taken outside, which has been done here, and the remaining portion that is all there is basically written here. And as you can see, this whole portion is basically the z transform equation of x of n. The only thing is that now instead of n we are having p. Now you might be thinking how we have changed this limit of the summation from n to p. All you have to do is see, if n is equal to minus infinity, then p is how much? P is going to be equal to minus infinity minus m, correct? Which is actually how much? Minus infinity itself. Whereas if n is equal to plus infinity, then p is equal to plus infinity minus m, which is again what? It is plus infinity. So the limit itself changes to p plus infinity minus infinity plus infinity. So now with all of this, what do we see? We see that, let me rub this. We see that what we have got is that the original function of z transform of x of n, that is getting multiplied with z of minus n. So in conclusion I can write that the z transform of x of n minus m is z raised to power minus m into x of z. And where will this new x of z, this new x of z will exist? See, we already know that x of z has some region of convergence R. Now for this whole function to exist, we will see that this has to also exist. That means this should not be infinity. For this not to be infinity, that means 1 by z raised to power m, this will not exist, or this will be having a value of infinity only if z is equal to 0. Okay, so the new function, that is z raised to power minus m x of z, will have an ROC of R except at the origin. That means you should not take the value of z is equal to 0. Similarly here it will be, that means for the case of plus, it will be z raised to power m, and for this one not to be infinity, the value of z should not be infinity. Okay, the value of z should not be infinity. With that we will say that it will be the ROC R except at infinity. Now here see, I have written something, that is, this is for the 0 initial condition. That means I want you to write what will happen with initial condition. That means if there is initial condition, I want you to write a new, I have not written here, but I want you to write here that if there is initial condition, then there will be plus z raised to power minus m summation k is equal to 1 to m x of small x of minus k into z raised to power k. Okay, this will be if there is no 0 initial condition. That means if there is initial condition. Similarly for this part, this equation, it will be plus z raised to, so not plus, sorry, minus z raised to power m summation k is equal to 1 to m x of k z raised to power minus k. Okay, what I have written in green color is when we are having some 0 that means when we are having some initial condition. For zero initial condition, these two won't be there. That means this whole green equation will not be there. Okay, so that you can write as separately. So first you can write that this is for zero initial condition, and for initial condition, if it is non-zero, then the equation will be basically with the green. So then, okay, generally, but this is the equation. So hence we have proved the time shifting property. Next is multiplication by an exponential sequence property. That means if you are having a function x of n whose x of z you know already, or you have calculated, and you know the region of convergence also, then multiplying that x of n with some complex function a, see a is a complex number, a raised to power n, is as good as in the in the z transform side, change z to be z by a. So you can directly get the z transform. If you already know this, then you can directly get the z transform by just substituting instead of z, you substitute z by a. Wherever you find z, substitute it with z by a and you will get the answer. And same is the case with ROC also, and that's why it is written like this. That means suppose if you are having ROC which says z should be greater than some value b, then instead of that you will write z by a should be greater than b, or z should be greater than a, that is magnitude of a into b. And that is why they have written that ROC is multiplying a with that particular region. Okay, so let us prove this. Now the proof is quite simple. So we know that the equation of z transform of a raised to power n x of n will be, instead of x of n, I am going to write a raised to power n x of n, where this a raised to power n and z raised to power minus n, both of these can be combined together. And see, suppose if I am having some a raised to power n and z raised to power minus n, I can write that as a raised to power n, and z raised to power minus n I can write as z raised to power minus n into n. Now both of them are having a power of n, so I can basically take both a and z inverse together and write them as totally the power of n. And that is how we have got from here to this, where instead of now taking a raised to power, instead of taking a raised to power n, what we have done is, in this particular case, we have taken a raised to power. So how has the ROC changed? The ROC is now scaled, because as I previously told, if you are having the old ROC was some region z is less than or greater than b, then instead of z I will write now z by a greater than b, where this z by a magnitude can be written as magnitude of z divided by magnitude of a, where this magnitude of a can be taken the other side, and I will write z has to be greater than magnitude of a into b. So what has happened? In the old ROC, I have multiplied a magnitude, correct? So that is what the thing is, that now I am saying that the new ROC will be ROC a multiplied with r. So that is what is the multiplication by an exponential sequence, wherein when you multiply with a raised to power n, all that is happening is z is changing to z by a. Okay, Thank you. Now if we go by that, see here we are having a raised to power n. A is basically a complex number, so if I am going to take the complex number to be a is, suppose I am going to take the complex number to be e raised to power j omega, then a raised to power n will be e raised to power j omega n, which is written here. So if I am going to multiply with this, then it is as good as dividing z with e raised to power j omega, or I can write it as multiplied with e raised to power minus j omega, where if I take e raised to power j omega, then if I want to take it into denominator, I will write it as 1 by e raised to power minus j omega, or if it is at the denominator it is e raised to power j omega, then I can write it as e raised to power minus j omega in the numerator. This is something that you already know. Okay, so that is what we have used here. So e raised to power j omega, if you multiply with some e raised to power j omega n, then it is as good as taking z and dividing it with e raised to power j omega. Now you might be thinking why we have basically used this particular why we have used this. Nothing, this can be used for the case of finding out what is the z transform of cosine or sine function, that you have already seen. Anyway, next is the time reversal property, which says that if you are having function x of n whose z transform is x of z with an ROC of r, then I can find out x of minus n, that means n is getting just minus n. All for doing that is, instead of z I will substitute it with 1 by z. That means basically I am going to substitute z with z inverse. And what is z inverse? Z inverse is 1 by z. That is what this property is saying, that if you are having in n, if you are going to write minus n, that means you are going to reverse the time. All that you are going to do is, instead of z you can write z inverse, that is 1 by z. And what happens to the ROC? Whatever is the ROC, that ROC is going to change as 1 by r. So it means what? It means, see, if you are having the previous ROC, which was some, let's say some z is greater than a. Okay, this is what you had got the previous case. Suppose the ROC is z greater than a, then the new ROC will be 1 by z greater than a, which becomes what? 1 by magnitude of z is greater than a. Or you can bring z this side and you can take a the other side, which becomes 1 by a. Am I correct? So what has happened? All it has done is that z was greater than a, as now it has become less than 1 by a. That means it has straight away got flipped. And that is what the region of convergence has got flipped to 1 by r. Let us prove this. We know that x of minus n, instead of writing n, if I am going to write minus n, and then in the equation it will become minus n, x of minus n, rest all the equation will remain same. Now I will put, instead of minus n, p. So if I am going to put minus n as p, then obviously, see, if I am having n minus n as p, then the limit of minus infinity, if I put minus infinity here, it will be minus of minus infinity, so the limit will become plus infinity, and if it is plus infinity, then it will become minus infinity. So that is what has happened here. The limit has gone from infinity to minus infinity. Instead of minus n, I have replaced it with p, and here also instead of minus n, I have replaced it with p. Okay, now what is to be noted here is that, in this particular equation, if it has to look something like this, it has to be z raised to power minus something, isn't it? So I can write this as z of minus 1 the whole raised to power minus p, and that is what I am writing it here. And I have just flipped the limit, so it is minus infinity to infinity x of p, Instead of z, I am having z inverse the whole raised to power minus p. Okay, in that case, this equation is similar to the equation of z raised to power x of z, with the difference that instead of x of z, now instead of z I am having z inverse, which is x of 1 by z, and that is what is basically written here. Therefore, what follows is that if you are having a function and whom you have done the time reversal, that instead of x of z you will write x of 1 by z, and the ROC is basically flipped. Next is the time expansion property. Only time expansion property will be possible. You cannot have a time reduction property. Okay, so in case of time scaling, generally you either multiply or divide, where the property here is only for the case of divide, or what is basically called as time expansion. So if you are having x of n whose whose z transform you already know is x of z, then instead of n, if it is being replaced with n by k, that all that is happening in the other side is instead of x of z, wherever you have z, replace it with z raised to power k. And what happens to the ROC? ROC is going to be 1 by ROC is the original previous ROC raised to 1 by k. Let us see what is the meaning of that. See, if previously you had some value of z is greater than some magnitude a, then the new one will be z raised to power some k. Okay, z raised to power some k, where if I am going to multiply, or both the side I am going to raise to with 1 by k, then I will get z raised to power k the whole raised to power 1 by k is greater than a magnitude raised to power 1 by k, where you can say that k and 1 by k will basically cancel off, and you will get magnitude of z is greater than a raised to power 1 by k, and that is what is basically represented by this, that the ROC is getting r raised to power 1 by k. Okay, so let us prove this, that how this will come about. According to the equation of z transform, z of x raised to power n by k is basically summation n is equal to minus infinity to infinity x of n by k z raised to power minus n, and now instead of n by k I am going to substitute it with n by k being equal to p. So if n is equal to minus infinity, you can see that p will be also minus infinity. If n is equal to plus infinity, then you can see that the value of p will be also equal to infinity plus infinity. So there is a straightforward change in the summation. N minus n by k basically gets replaced with p, and instead of n, since it is n by k is equal to p, so it's as good as writing n is equal to p into k, and that is what we have done here. Now z raised to power minus p into k can be as such written as z of k the whole raised to power minus p, and that is what we have done here. So if you look at this particular equation, what do you see? If you look at this particular equation, you see this as the equation of z transform of x of p, which is actually x of n, but instead of z, all you have got is z of k. Okay, so therefore the new value of z x of z will be, instead of z I am having z raised to power k, and this is what we have written of the ROC, that this equation is the equation of z transform with z being replaced by z raised to power k. Therefore the new ROC which will be defined will be, instead of z I will write z raised to power k. So the new ROC will be this, that we have already shown. Next is multiplication by n or differentiation in the z domain property. according to this property, if suppose you are having a function x of n whose z transform you already know is x of z, which has a region of convergence R, where some region of convergence R, then if you are multiplying n with x of n, all you have to do is differentiate x of z with respect to z and multiply with minus z. The ROC remains the same. There is no change in ROC because z is not changing. Okay, so if you multiply x of n with some n value, all you have to do is differentiate x of z and multiply it with minus z. So let us prove this. So we already know that x of z can be obtained by the equation, simple equation of z transform, which is n is equal to minus infinity to infinity x of n z raised to power minus n. Now if I am going to differentiate this x of z, so if I am going to differentiate x of z with respect to dz, then I will differentiate this whole right hand side also. So if I am going to differentiate this whole right hand side, in this whole right hand side, all the functions or all the values are with respect to n except this one, correct? So the differentiation will only apply to that factor, and we know that z raised to power minus n, if I am going to differentiate with respect to z, it is as good as writing z raised to power minus n minus 1, correct? Which can be written as z raised to power minus n into z raised to power minus 1, correct? And that is what we are, n into z raised to power minus n minus 1, so that minus n into, so this is minus n, and that minus n I will write it here also. Sorry. So it is minus n into z raised to power minus n into z inverse, and that is what we are having here. So that z inverse, z raised to power minus 1, I will take outside, even this negative value I will take outside, and whatever remains is what? Whatever remains here is basically the z transform of nxn, correct? Whatever remains is basically the z transform of nxn. Okay, so if I take this the other side, that means if I take it in this side, so let me write that. If I take that minus 1 z inverse the other side, it will become, the minus will come as minus itself, whereas z will inverse will become z. Okay, that's how we prove this. Thank you. So we can conclude in similar lines that if instead of n it is some n raised to power k, then you have to differentiate k times, multiply z k times, and multiply minus 1 also k times. This is a simple extension of this particular property. So if you are multiplying with n, it is like this. If you are multiplying with n square, then minus 1 into minus 1 will become plus, z will become z square, and instead of differentiating it one time, you will differentiate it two times. Thank you.